Okay, so here we are trying to do polynomials again from chapter 5. Hopefully this time we have a voice picture sync. Alright, so one of the things that we looked at in chapter 5 was function notation, and that was the y equals f of x. And if you remember from grade 10, that this is just a fancy way of writing out equations. Okay, so I just made up this 2x squared plus 3x plus 1. So where did it come from? I made it up. So one of the things with function notation is we could do f of 2. Actually, I use 2 too often, so I think I'll use 3. 2 times 3 squared equals and we can just simplify. So that's one of the things we did. We could also do more complicated things. For instance, I could replace this with a, I don't know, let's do a 3a. Okay, so now we'll have 9a squared, 9a, and we'll be finished that. Okay, so whatever we find in here gets replaces the x. Anyway, okay, so one of the things, if we had two functions, I'll use the same f of x, but what if I had a g of x that was 5x minus 7? Then we can add functions, f plus g of x, or we could just write that f of x plus g of x. And that's just take the two functions, 2x squared plus 3x, and add on the other one. So now like terms, we'll get 2x squared plus 8x minus 6. And we could continue to simplify that if possible. Not too worried about it. We can also times. So we can 2x squared plus 3x plus 1 times that. And I'm not going to work that out. It will be something like 10x squared. Oops, not squared. Cubed plus minus 15 minus 14 x squared, and I will just say that there will be more stuff. This should all be review from grade 10. We can divide, of course. And we'll be looking at these types of rational functions. That's what this is. And we'll be looking at solving these. Rational function is a polynomial divided by a polynomial. Polynomial divided by a polynomial. And with this, we have to worry about NPVs. The bottom can't be 0. But we'll look at that more later. What's a bit new this year, and I'm going to get two different functions here. Well, actually, you can use the same ones. F of x equals 2x squared plus 3x is a composite. And that's fg of x. Okay, there's the symbol for composite. It is hollow, it's a circle. Looks like a times in the same position, except it is hollow. And that's just a fancy way of writing f of g of x, which means wherever I see an x in the f function, I'm going to replace it with g of x. So that will become 2 gx squared plus 3 g of x plus 1, 2 5x minus 7 squared plus 3 5x minus 7 plus 1, and then you can continue to simplify, which again I'm not going to finish. Now be aware that this is not timesing. Okay, we saw when we timesed right here, we ended up with a 10x cubed. There's going to be no 10x cubed here. I will end up with a 10x squared, or no, actually a 50x squared from this stuff here. So composite of functions. That was new. Now, other things you were supposed to learn out of this chapter is how to do a quick graph. A polynomial function. There were other graphs we were supposed to look at, but we never did. That is terrible handwriting, by the way. Anyway, types of roots. How does it cross the x-axis? Three types of roots. X minus a if that's a. This is called a single root. Goes straight through the x-axis. This is the x-axis. Next type of root that we have is often referred to as a double root, but realistically it is a even root, and it comes about when you have a even exponent. It's the exponent here that drives things, just like the degree. So double root comes down and just touches, does not actually cross, which is why I have cross in quotations. Okay? So a double root, and yes, there's nothing to stop it from going like that if we had negative x minus a squared. Remember, the negative flips over the x-axis. Okay, the next type of root that we have is, and I'm going to exaggerate this a little bit, is a triple root, or odd. And that will be to the third power, or to the fifth, seventh. Again, it's the exponent driving the root. Okay, we usually think about it as a triple root, but it comes about when the exponent is odd. So 3 types of roots. Get them all on the screen there. Single root, straight through. Double root, just touching. Triple root goes through at a curve. That's the basis you need to do to draw a graph. That and the y-intercept, which you can usually find. So, an example of what you would do here. I give you an equation. F of x equals x minus 1 squared x plus 2 cubed. And I probably won't give it to you in this form, but this is what I'm going to do right now. So what does this look like? Okay, well, let's see. I'm going to get an x equals 0 from here. You can take the 3 pieces. X equals 0. X minus 1 equals 0. X equals 1. X plus 2 equals 0. X equals negative 2. And we're going to get a single root, single root, double root, triple root. So putting those numbers on there, x equals 0, x equals negative 2, x equals 1. So now how is it going to look? Well, the degree of this thing is 3 plus 2 plus 1. So we get a degree 6. And we can see that there's no negative sign out front. So if I multiplied all the x's together, it would be positive. Now here's something else to keep in mind in general. I'll come back up. Okay. Even degrees tend to look like that. Odd degrees tend to look like that. Okay, well, I did things in this case where I told you to put a big number in for x and see what type of answer you get. You know, realistically, even degrees are always going to be kind of parabola shaped. Not exactly a parabola, but kind of a parabola. Odd degrees will tend to have this type of shape. Now there could be more bumps going on. For example, it could be something like that. That's still even because the general flow of it looks like that. So things to keep in mind. So back to our graph up here. Okay, so I have an even degree. So I know the graph is going to go from there to there, roughly, because it's positive out front. And let's see, single root, x equals 2 was a triple root. So I know if a triple root is going to come down, kind of go a little flat through the root, and then through like that. So there is my triple. And it's triple because of that. Okay, I have to come back to this 0. Now 0 was a single root, so it's going to go straight through. So there's my single. And it's single because the exponent is 1. Now I have to come back down to make my other one, and I don't know if I can erase just a little piece of something. No. Need a finer eraser. Ooh. Puts things back. There we go. Double root comes down and just touches. So there is double root coming from that exponent. And that's the basic shape. Now you don't know exactly where these bumps are, but that's for another higher level math course. But there's a basic shape of the graph. Other things we're supposed to know about functions. We're supposed to know about the inverse. Of a function. Okay. F. Now remember, this is bad notation, not an exponent. You will lose big marks if I ever see anything like that. Not true. That is just telling me I have an inverse. The key to an inverse, the main idea, is there's an XY swap. Okay, you switch those. And then once you switch that, that has ramifications for domains and ranges and how the graph looks, all sorts of things. But this is the key to it. So let's do an example. We'll do an easy one. F of x equals x squared plus 4. Well, what does it look like? Quick graph. Remember, parabola lifted up 4. Even function. There's what it looks like. Okay, we can say domain. Remember, this was the easy, cheap answer. Range. There's the range. Hopefully we remember that. Okay, find the inverse. Okay, to find the inverse, I swap the x and the y around. So, y equals x squared plus 4. And that's not mathematical notation. I just do it to remind myself what the heck I'm doing. Solve for y. Okay, so we get x minus 4, y squared, y equals plus or minus. Don't forget the plus or minus because you had to supply the square root sign. There is the inverse of the function. we're done. What does it look like? Well, get some proper axes here. Okay. Here's the function. The inverse, remember, reflects through the y equals x line. Now, we also, this switching of x, y means the point switch. There's the point 0, 4. So on the inverse, I'm going to look for the point 4, 0. Again, there's the switch of x and y. The graph opens up. It'll now open to the side. There's what it'll look like, noting that this is not a function because it fails the vertical line test. So inverses don't always produce functions. You may start with a function, you don't necessarily end up with one. Or you could start with something that's not a function and end up with one if we went the other way. Okay, so if we look at this, this has some interesting properties. If I look at the function, the domain was x, all real numbers. The range, y bigger than or equal to 4. If I look at the inverse domain, is now x is bigger than 4 because I only use x's that are from here on out. I'm not using any x's anywhere else. The range is all real numbers. So again, we see this switch. The range became the domain. The domain became the range. So we get this switching back and forth. The main thing, okay, all to do with what I said was the main idea that we switch this around. By doing that, domain and ranges switch around. Points switch around. And that's an inverse. How do I know if I have an inverse? It's always a question. How do we know for sure we have an inverse? If you have an inverse, then when you do the composition, and it doesn't matter in what order, composition is usually gets different answers, you will always equal x. That when you put the two functions inside of each other, doesn't matter which one inside of which one, you will always get x. Okay, function move 2 steps back, inverse move 2 steps forward. You're back where you started. So in this case, I'll look at this composition. So I had a function of x squared plus 4. The inverse was plus or minus the square root of x minus 4. When I put these two together, f composite inverse, we get which is equal to plus or minus the square root of x minus 4 squared plus 4, which is just equal to x minus 4 plus 4 equals x. Ta-da! Exactly what I said it would be, because it has to happen. So if you had given two functions and you're asked, are these inverses, do a composite of the two functions. If you end up with x, they're inverses. And that is the end of this video. So we are done. Okay, so key points that I want you to get out of this were the different types of roots, or let's start with doing composite of functions. There's composites, the types of roots, single roots, double roots, triple roots, and how they look on a graph and how to do a quick graph, how to find an inverse of a function, how to graph an inverse of a function, noting a domain and range swap, and how do you test if you have an inverse. And that's it. We're done.